introduced in the first place. Okay. So, but before that, I'll introduce myself. So, my name is Osama Shaikh. I'm working as a solution architect in Microsoft. You could say Microsoft sales organization or pre-sales organization. So, I deal with solutioning of architecture entirely on Azure, more or less including all the Azure services. Okay. So this is on me now. Today we're talking about GraphRAG, and I've done this session multiple times now. So the reason for GraphRAG uh, is you could see it leverages a knowledge graph as a database. Now the image that you see at the right side of the screen, right, in different colors and wave-like line, that is actually a representation or visualization of a graph database. So this is a representation of a data set. The data set is written in the text below, which is behind the tech podcast. This is a podcast introduced by Microsoft CTO called Kevin Scott. So all the podcast transcripts which Kevin has done, we've included that in the knowledge graph, and this is how it looks. So if you see here, there are multiple entities here. When I say entities, these are basically small circles or dots. So if you see, I don't know if you guys can see my cursor. This particular cursor you see. This is basically Kevin's, because Kevin is an entity. We'll talk more about what is entities and everything else later. And it has a lot of relations with other entities, right? Different colors. Different colors or different circles represent different topics, different content in this session. So this is Kevin. There might be some dots with green, which talks about tech. Some talk about pharmacy. Some talk about biotech. So different categories have been placed with different colors and different relations. And thickness and thinness based on the relations Kevin had in the entire podcast. So this is a typical representation. We'll talk more what this actually means later in the course. Okay. So next we'll see. Next we'll see how the GraphRAGs basically in action. So this GraphRAG is a solution published by Microsoft Research, I think in the month of March this year. And Jonathan Larson was the guy who actually did a research as a data scientist in Microsoft, who did research and eventually come with a white paper for GraphRAG. And this is completely open sourced by Microsoft for everyone else to leverage. Now, this is another example before we even talk about to see it in action why GraphRAG actually matters. Okay. So next, yeah. If you see this slide, this is a slide deck which leverages Copilot. Now, when we launched Copilot earlier, right, this was baseline RAG. I mean, very standard baseline RAG it was leveraging. The RAG was basically your data set in your computer laptop, and using that, it gives you a response. So if you see on top, this is Jonathan's screenshot, which say he came back from vacation and he asked Copilot, tell me what all things I've missed or catch me up on the last 2 weeks since I was on vacation. Now Copilot, the center of the screen, there is an entire response Copilot generated using the baseline, the standard RAG or the graphen. You see, it generated a lot of content, right? Now, the only important thing in this is the one which is highlighted in the green box. So this is basically the key piece of information. And most of the key information which is written outside, which it had not captured. So it captured a lot of information, but many informations are irrelevant. For example, he was invited to a AWS summit, which was just on a kind of a spam email, right? It shouldn't come up. There was no interaction in this email. So, but it came up in the notable communication, which was not. So, a lot of information, whether it is relevant or not relevant, is pulled up by Copilot. Now, this is a second Copilot. Now, in this, the GraphRAG is connected with Microsoft 365 using an internal plugin that we were testing. The same thing, when we plugged GraphRAG to the entire Microsoft 365 content, this is the response which was missing in the previous meeting. So all of this highlighted text, which Jonathan is working or engaged in all this planning, is actually relevant to him. So the reason it was able to understand is because the way GraphRAG construct the knowledge graph database, right? It does it based on the entities, based in the main subject of the dataset, which is Jonathan himself, and then several topics Jonathan involved. For example, he's working on GraphRAG project from quite a while, and then several AI projects. So all this would be its sub community. So there's a concept called community in GraphRAG, which we'll also discuss later in the course. Okay. Now, what was the challenges with data set? Now, private data, basically RAG is needed because you have a private data and you want to use the LLMs to query or act on your private data, because LLM knows general information but doesn't know your private data, your organization information. So that is the reason RAG came in the first place. And then, so in the next slide, next few slides, I'll talk what is RAG basically, why it is introduced, and how we are solving issues which typically RAG can't. Okay, so in this private data, when the RAG is introduced, so you can ask questions. So this is very good. So RAG is very good with the precision-based question and answers. Okay? For example, you're developing a bot, right? Developing a bot of your product, say PlayStation, right? Your company, Sony, who's launching PS5 or whatnot, and you introduce a bot for it using a RAG. Then asking, okay, what disk it has, what is the graphic size, memory, controller, whatnot. It can give you very precise information using that, because this is a very precise information uh, carved in a data set to a RAG pattern. So a precision-based data set or question works absolutely fine with RAG. There's no need for leveraging GraphRAG. So that is the whole point when I talk to customers. We mentioned you probably don't need GraphRAG if you don't if your use case is only a customer support bot or something of that similar. You only need when you have a bigger problem, if you have a data set which is way larger than and way abstract, right? Not linked with each other, but rather an abstract data set. So that is where GraphRAG would be more useful. So here is an example wherein so RAG would fail when you ask an information or an information that actually needs to look up across multiple data sets. So example, catch me up on the last 2 weeks of email. Right? Now catch me up, there's a lot of emails with a lot of different topic. Which one is relevant and which one is not? That is where it is not able to have a context, because the way RAG works, which we will see in the later courses, it basically do a vectorization of your data sets into a vector DB. And once you have a data set, it performs a semantic search. Semantic search is basically based on vectorization. Vectorization, you give a word, a vector number, and based on that, you perform a semantic search. For example, if I make a query, tell me the type of dog mentioned in the data set. So it might introduce even wolf or maybe a nearby family of a dog in a result also, considering how the semantic search is working. But in a GraphRAG, it actually understands the relation between the dataset. If there are dataset about several topics, okay, what topic is this? Not doing a semantic search, but rather having a holistic view of the entire data and then multiple subjects and how these subjects are linked. If I ask, let's say, how many breeds of dogs are here, or Then it understands, okay, this is the data set of docs, what is the relation, what it is talking about, what is the breed is talking about. And it can summarize, LLM summarize the entire response and give an answer to us. So this is a two problem. The first is when you ask an abstract question like this, which involves querying a lot of multiple data sets, it tends to fail. Not every time, but it tends to fail or hallucinate. It gives you data which is not relevant to you. The second problem is when the data set is too large and the loss in the middle phenomenon, right? Like I said, when you, so let's say, I mean, this is also the case with one of the customers that I was dealing with, wherein you data have a too large of a data set, multiple, uh, let's say, a cricket commentary, right? You have a cricket commentary of several hundred of matches, and then you're trying to summarize it or get a theme of it, or understand, okay, what usually happens in this page, or understand the theme of it. Let's say you ask a question, if you have a multiple transcript of a commentary of a cricket match, let's say hundreds or thousands of cricket matches, let's say played in India, and if you ask us a question, okay, what is typical pitch condition? Is it a favorable to batter or bowler? Then it more or less either fall flat or hallucinate, because it simply has a semantic search capability wherein it is doing taking a keyword of your question and doing a semantic search rather than holistically understanding, okay, what has happened throughout, what is the overall runs combined, and what is the total conditions for bowlers and batters, and what does the transcript says about the conditions of pitches overall in India, and then eventually responds. So it doesn't really look up to that and simply make a semantic search based on the question you prompt you ask. So data, I think next few slides I will cover how typically RAG works, and a lot of problem that we're trying to solve via RAG can be solved if you do a very effective chunking, which is a strategy in a RAG pattern. So this is a typical Azure. I mean, this is an open source architecture. If you're developing a kind of a bot application on a RAG base, right? So in this, you have a data store which is on the left side, right? And then you want to have the data store vectorized. So the vector DB here used is Azure AI Search. And then this is the basically the UI or the app part of this. Now you have different data sets in SQL table, blob storage, object storage, document DB collection, different data sets, and you want to vectorize this to build a RAG for yourself. Now, while doing a vectorization, you would have to, it would not simply take the entire DB and do a vectorize in one go. You would have to define a chunking strategy. So what is the chunking strategy? You would have to give the size for the chunks. Okay. Now there are best practices on chunks, how the chunks should be. So typically, what we recommend is if you want a very accurate information of RAG response, make sure in each chunk, let's say you have a text file of a single page, and if you want to do a chunk of it, you make sure when you do a chunk, you have an overlay of at least 20%. So let's say if there's a description about myself, there would be a chunk, multiple chunks for it. Let's say my name is Osama, I work at Microsoft in a solutions architect team. Then there would be another chunk, okay, I'm working pre-sales organization, I work. So I want to make sure there's an overlay of at least one or two statement wherein it could relate the data. If I make the chunk completely isolated, then the hallucination increases or either the response becomes flat. So the chunking also, there are multiple chunking strategies, by the way. I've just listed out two. There are way a lot of chunking strategies, which maybe we can cover detail. And a lot of problems typically when we build a RAG solution for a customer get solved if they have very effective chunking, right? But again, there are cases where regardless of what you do, chunking cannot help you. So that is what we were discussing today. So this is a typical overview of RAG pattern. a user send a question. The question basically converts into a vectors using the embedding model ADA 02 in OpenAI. Once it is converted, you perform a hybrid search on your vectorized data and then get, I mean, including the semantic search, and then get whatever the result comes back with semantic search, send it to LLM, LLM summarize it in a human readable form. So this is, the things will change here. This is the part where it will change. These two boxes that you see, this is what we would change in a GraphRAG, which we'll see later. Yeah, I think this is again limitation of RAG pattern. We talk uh, about this in an earlier slide. This is a sample piece of question, what how it can work really well for a specific question. For example, if you ask what is the wattage does this product require, like we take an example of PlayStation 5, how much graphics or a memory does this PlayStation have? It will give you precise information immediately. But if you ask uh, a question like what are the themes of this report, let's say you send a data set in a RAG pattern and you ask me what is the theme of this data. So what it would rather do is it will take the word theme in your prompt and then do a semantic search in the data set. So if it finds any keyword in the semantic ranking based on themes, right, or similar, it will simply give you the string from that or more or less a readable format. It says in the data set it talks about some other theme meaning, not the report meaning, some other theme string. It will simply give you that as a response. Rather than understanding, we're asking about the entire report theme, not actually the content within it. So that's usually happen with the RAG pattern. We have a couple of more questions here listed, wherein it could struggle or hallucinate in such scenarios. What all products currently being supported by API gateway? List again the other two questions that we have, right? This is basically sourcing multiple data sets. So here we're trying to query multiple data sets, and that is where the lost in the middle attack that we talked about earlier, right? The scenario happened with RAG, and eventually it gives you either irrelevant information or maybe give one liner and fall flat. This is the context. So one example I could give you wherein I was working with a customer. Now I was building HR application, so maybe in a kind of an HR bot. Now, what the HR team wanted is they typically scan resumes first by the HR team, and then based on when they scan, it would further go through that first level of technical screening, and then eventually land an in-person interview. So what they had to say is, if you could build a bot, right, which could give us, let's say we query, I only need, let's say I need someone with JavaScript skill set expertise with more than 10 years of experience. So when we're using a RAG, what used to happen is it either gives you a resume with JavaScript or it either gives you people with, so it clubbed a result. You get a JavaScript resource, but you also get a result wherein a lot of people who has more than 10 years of experience overall. So 10 years of experience, which is an overall number for a lot of resume. And there are some people in JavaScript. So this is how the cumulative result was coming, which was not accurate, right? And you could do prompt engineering, trying to optimize it, a lot of things. The problem is the way the data set was working, it was sourcing a lot of data from the lot of resumes over the college campus hires or college campus events, right? And then fit it into here. Now, if let's say if they want to ask, give me 10 resources from top 2 or top 3 colleges of India, even then it was to fall flat or give hallucinate. So not an accurate, and that is where I actually a few months ago, I mean 3-4 months ago, I eventually land up in GraphRAG, and we explored GraphRAG, and eventually this solved a lot of the problem. But there are downsides for GraphRAG, which we'll also cover, and that is where the decision or the trade-off we will have to look at. Okay. Any questions so far, team? Okay, I take that as a no.
Hi, am I audible? Hello.
Yeah, yes, you are.
Hi, this is Mayur here. So I've been listening to. Joined a little bit late, so pardon me for if I'm asking a question which might have asked before. So in typical RAG, usually we use the products from LangChain uh, and other LangGraph and other solutions. So I understand the basic tactics, what you have explained between difference between and problems with the uh, uh, with this RAG and the entire ecosystem out of it. But
Mhm.
isn't it true that RAG has been typically used with large language models, and nowadays because the context token has been introduced in a very large scale, which is available with OpenAI as well as with different providers, as well as in the open source LLM, the large tokens are available. Uh, I'm trying to understand whether RAG really does make sense in today's world in front of the uh, large chunk of uh, tokens available, context window available.
I know. Yeah, got your question. I know we have increased context window. We initially started with 8K. Now GPT-4 gives you 128K, and I think some version of Gemini gives you up to a million token also, right, in
Million
the
token,
context window,
right? Yeah,
right? I understand. But there are problems. I'll cover that. So there is a separate section wherein we
sure,
are covering the context window in the RAG also. Okay, and maybe we can discuss that there. Okay.
sure.
Okay, I'll move on to the next slide. Yeah, this is a description on GraphRAG. I mean, I've been talking GraphRAG a lot. So, extracting a knowledge graph by a data set, creating a knowledge graph from a data set, building a, I think I haven't spoken about community, generating summaries and using structures and data. So, extracting knowledge, taking a data set and creating a knowledge graph out of it. Okay, that is one part. But when you create one, if you recall, I've shown you uh, a slide in the start, right? Which is, if I could show you, you see a screen? So when you create a graph rack and you visualize it using any of the native tool, let's say Neo4j, there are multiple tools available wherein you can visualize your data set also. So in this visualization, you see a lot of circles or dots, right? So each dot has a multiple overlay. So when I say overlay, it means let's say this is a level one of communities, and then there are level two and level three. So what do I mean is, let's say I've given a data set. In this example, we're using a podcast data set, a transcript. And typically in the postcard, you have a conversation all over the topic, right? Everything from tech, from bio, from wars, whatnot, right? Now, what typically happens, let's say talking about tech, there's a community or there's a particular color. Let's say there's a color for pink, which denotes all the conversations around AI. Now, when you go to, there would be a community layer two, wherein within AI, okay, what all discuss within AI? Okay, we're discussing RAG, we're discussing GraphRAG, we're discussing Gemini, we're using OpenAI, we're using LangChain. And then each of this topic will act as its own subject and have a multiple relations to it. So there would be a multiple layers of a community, wherein you have one layer, which is a very high level. And we will discuss this in also search. So when you do a search, we also have a concept called having a local search and a global search. And you can, when you build an application like GraphRAG, you can actually target that. Okay, I want to only do a, let's say, if there is a question and you build your data set only on AI or only you're only allowing question on AI. So even though you have a large podcast data set, you're only subsetting it. Okay, only respond from the data set of AI. So this is a local search wherein every time I send a response, only this, let's say a pink denotation, right, or ping entities would be used for searching and then responding for a precision answer. So in this, you won't get a entire holistic view of relation, but you would get holistic view of AI at least. This is what I was trying to. So that is what the communities is. Okay. Now communities basically depends upon entities we talk about. So entities is each main subject, each dot which is bigger or small is described as entities, and the relation between them defines community. So for two circles, you might have multiple connections back and forth because these are two discussed topics. For example, in our case, RAG would have one circle and maybe the AI or a GraphRAG would be another bigger circle wherein these two would have a lot of exchange of conversation or relation. So this would be shown as a bigger circle in our GraphRAG if there would be a visualization of our conversation or of our talk GraphRAG in that sense. And then generating summaries. Once you have built a community hierarchy, you generate a summaries out of it. Okay, this is talking about AI. This has a relation with GraphRAG, RAG, OpenAI, Gemini, or whatnot. Generating a summaries around the relations and using this structure when responding back. So I'll go to the components of GraphRAG now, which we talk about, right? So yeah, knowledge graph components. I mean, with an example of an Einstein here. So let's say there's a data set for Einstein in the knowledge graph. So what entities would be in that sense is entities as in the main subject would be Einstein himself. The relativity theory which uh, he published, which gave him a lot of fame. And then the university, this is some examples of which would be the one which has a more common relation or more conversation or more data set that becomes its own entity. Attribute becomes a delta. I mean, attribute is attribute wherein the characteristic or properties of the data. For example, here I've given an example of birth date of an Einstein, which is March 14. So that is why it takes it as an attribute. If someone comes with that question and respond back immediately because that's an attribute to an entity. So each entity has a set of attribute. This is one of them based on the data set. Relationship, which I talk about, wherein a lot of relation that I think if I show this, and I mean this is actual graph of the Behind the Tech podcast, and if you see, if I don't know if I can't zoom actually, but all the back and forth communication that you see here, right? These are actually the relation. So the one you see with a very thick lining, that is actually having a very strong relationship because if I give an example of, let's say, in a human example of friends, right? You might have group of friends, 10 friends, but you only interact with two, three of them very oftenly, right? So you would have a very strong bond between, let's say if I interact with Kasam, right? Me and Kasam would have a very strong bond. But let's say Mayur, right? Mayur would have a very single relation channel or very less because we hardly speak. So that is maybe an analogy of a relationship in a graph. And that is how I understand, okay, this person is important. So Kasam is important to Sama. Mayur might not be. So when we answer question, it would also look at the angle of Kasam. What is Kasam doing? In the cancel, I mean, in the analogy of friends. So that is how it responds. Yeah, nodes and edges is basically edges are the sub entities, which is wherein node is the parent entities and edges is a small entities that are relationship or the peripheral entities around it. That is the edges. Okay, so this is a workflow wherein A typical RAG is basically do a chunking based on data model and vectorize that into a vector database. So you have a data set. Let's say I have a data set of this podcast. I send this to a vector database using the data model and a appropriate chunking strategy. And then now all my data set are vectorized and there in the vector database. In our case, it is an AI search. And then a semantic search would perform on this data set to get a response. This is the standard or a basic RAG. Okay. In the case of GraphRAG, I think we'll see what will happen is when we do create a knowledge graph of a data set, right? It basically what happens is it doesn't do a vectorization, right? So it actually understand your data. So when let's say you have a set of data set or you written a set of blogs or whatnot, so it basically go through all your data set and understand the concept of it. So here in this example, there is a leader, Sylvia Marek, and then there is a CEO, Lucid Jacob, right? So you understand how these two are uh, main entities of this conversation and what is the relationship between. So you understand the entire context of the data set and then create a graph out of it. And then create a graph. This is the first layer of graph wherein a very high level community. So even in communities, there are multiple levels, level 0, 1, 2, 3. As you go deep down, based on it, if you have a very large data set, you might have multiple layers of community based on the different, uh, the kind of data you're dealing with. So from here, it creates a basic data set, which is level 0 community, a very high level information. And then as you need more specific conversation or a very detailed conversation or a detailed prompt in that sense, it would query based on the different layers of community if the data set is of that sort. Okay, so this is in how GraphRAG works. Like I said in the last example, so LLM extract knowledge graph. So knowledge graph is created. LLM is basically querying and extracting knowledge graph data set. And knowledge graph is responding. If you ask a question, tell me about who's Kevin Scott and what all genres he has talked about in his podcast. A sample question. So it will, okay, do a query in a knowledge graph. Now, Kevin Scott has one large entity in this entire transcript or a knowledge graph. And then it will check all the relations it has for different topics. Might have talked about AI, biotech, uh, pharma, COVID-19, whatnot. In each of this topic, which one the LLM extract? Okay, which one is basically fall into different genre? Okay, this is medical, this is biotech, this is tech, this is AI, and then give draft your response accordingly. So Kevin's responded. Kevin talked about AI, technology, biotech, uh, viruses, right? And then give your response back. So this is what describing here LMX talk knowledge capture semantic structure based on the community. Like I said, we talk about there are communities created. Communities are formed based on how the deeper the relationship is between two entities and edges. And then whenever someone asks a question about an entity, it check the relationship of that entity. Okay, what are the relationship of this entity? Which one has a strong relationship, which I should prioritize, and which has a very weak relation. So there is a concept called strong relation and a weak relation in community. So based on which entity has a strong and weak, it gives us a response back. Okay. So we'll talk about a demo that I've prepared. Again, using the same Behind the Tech podcast of Kevin Scott. Microsoft CTU. So what I'll do is I'll share my screen to the other one. So this is an app, I mean internal application that we published using a transcript of this podcast. It's a knowledge graph in the background. What we're doing is we have two data sets. One is each prompt is going to make a query to a RAG data set. I mean, in a RAG pattern. Another same prompt would be querying to a GraphRAG. And then we'll compare a response. This is for a comparison in this podcast. So a few questions saved so that the live demo could be smoothed out. Okay. Now we'll discuss in this podcast who talked about the MIT. So MIT is a institution in USA, wherein similar to our IIT. So you can see the basic RAG was pretty fast. It responded back to you in 1 second how many tokens you have used, made a one LLM call. And then it told that this was discussed by Danny Hills. So Danny Hills was a person who discussed about MIT. And that's all, we're done. And even GraphRAG, this is again, you see the number of tokens both. That's why I said there are downside of RAG also. So the token it has utilized is 600 in 6 lakh basically. 38 LLM calls in 14 seconds. Okay. So, and this is, it only talked about Danny Hills, but it understands Daniel Russ, Rodney Brooks, Rana, Steven, Drew. So many people which actually basically missed by basic math. So that is what the GraphRAG is. Because it has the understanding of the entire data set and all the entities, it can query each entities which had a MIT relation and then generate an LLM response back in a based on the community answers it got. Okay, so this is one. We'll take another example. Okay, so we'll mention this is like an abstract question, right? This is not a very pinpointed question. This is an abstract question. We'll see how that goes. So, what other universities? I mean, this is hundreds of podcast session transcript. So, around 900K token overall, if be precise, in a for an LLM. So, what other universities were discussed in the same episode with MIT? So, when anyone bought MIT, what other universities they bought up with? Very abstract question. Need to have a lot of referencing of a conversation back and forth. Let's see how that goes. Yeah, 5 seconds, and the response was there for this. I think here we have MIT, Caltech, and Stanford, and then Stanford. I mean, yeah, these three universities were discussed together in the entire podcast of hundreds of hours in Ken Scott. Wherein the GraphRAG was doing a global search. It says, okay, universities discuss MIT, Amherst, many, Harvard, Illinois, Virginia Tech, Iowa, Caltech, much more, right? I mean, this list goes on. So again, it's slow, but it is precise, it's accurate. This is fast, which is using basic RAG using GPT 3.5. GPT-4 basically, I'll be using GPT-4 on this. But it doesn't give you an accurate data or all over relevant data. A very, I would say, a pointed question now. I mean, this is an abstract, but not very abstract, but rather a very direct question. Let's see how that goes with these two. These two are trained with same data set, by the way. Yeah. Okay, so what creatures are discussed in the entire podcast with in this Behind the Tech podcast? Okay, so in basic RAG, again, 5 seconds. Spiders, crows, medieval shark. That's all. Now here, insects, insects, arachnids, microorganism. Other notable characters: crows, corvids, whales, frogs, dragons. So there are multiple, which was missed by again basic RAG, which was also a very pretty direct question to be honest. Yeah, not a very abstract question, but again, considering the holistic understanding of the data set, GraphRAG gives you. And we're doing a global search, so it's making a global search call into an entire data set, not doing a local search to a sub entity or a subtopic of a GraphRAG data set. So this is a demonstration how this would work. Again, this is significantly expensive if you know how the token consumption works in an AI world, but it isn't accurate. Again, that is the reason when I say GraphRAG is not for all. I mean, not for all use cases, only specific use cases. If you have that kind of data set, then it makes sense. And there is another thing which I would talk later in next couple of slides. How you should use it, considering it is an expensive, how you should use it. And so we'll talk about that also. Yeah, global versus local search. Again, I think I can show you some things. Uh, if I do a local search versus a global search, I can show you that also. Yeah, so that we have a context when you do the next slide. Local search is meaning it is doing a query in the subset of data in a graph, right? Not the entire graph, but subset of graph RAG. So in a subset of graph RAG, again, it is significantly fast, but it only came up with honeybees and spiders. That's all. So this is having crows and medieval shark spiders. This is only honeybees, which so each of the basic and the graph RAG has missed out some content. Local has missed out some creatures, but graph RAG list out multiple things. So yeah, you can use local search if there are use case for this in the data set, but might or might not relevant to you. But this is significantly cheaper and fast, more or less the same token size. And that is where we'll discuss what is global in search. Okay, so can you? I'm sharing the other screen. Okay.
Uh,
Yeah, Mayur.
yeah, I'm trying to post a question, but for some reason, I think my question is not being posted over here. So that's why I'm using voice. So Osama, I was wondering, are you using Neo4j as a database in the backend for this as well, for the graph, for this example?
No, this is Cosmos. We have our own internal Cosmos Graph API.
Okay. I tried some time back with uh, Open GraphRAG as well as with the Microsoft GraphRAG when Microsoft debuted it. And I have a lot of questions about it. I hope upcoming slides will discuss about that. I'm primarily more interested into uh, creating the relational GraphRAG, oh sorry, the GraphDB from the raw data. That part is still having very blur information available, but I hope in the upcoming slides probably you will identify it.
I mean, this is like an introductory session, so we haven't really have a slides on creating raw data.
Okay,
But I mean, I'll help you with. Maybe we can connect offline. You can
that would be a
post
great
me on
help.
LinkedIn, yeah,
Yeah,
LinkedIn or right, and then I
yeah,
can help
I
you
will
with
do.
it. Okay.
Okay, thank you, Sabah.
Okay. So this is which we see in the previous slide. GraphRAG local versus GraphRAG global. Now, you see the response local is significantly fast, less expensive, but not might not give you the accurate data. And the reason for that is this is an example of global search wherein it queries the entire knowledge graph, which is time consuming, right? Because you have so much data set and so much entities. So it is time consuming. So it takes a look of the entire graph and then generate a response back. In this example question is please give me a relation between a protein and a disease X, right? So the result looks like is gives you a, a direct answer, but also a relational information together. So protein A interacts with protein B, which is to influence gene Y. This is an additional information. And gene Y has been implicated with disease X. And protein is also pathway to often disrupt in disease X. So it is giving you an entire context how the protein A might be related with some disease. So let's say some protein is related with some disease. Why it is giving some context behind it in a global search because it has an holistic view. Okay, and and then this is a local search. Now, local search is focuses on a specific subgraph. Like let's say if we made a question about creatures, it specifically, if you recall, if I can share a slide, explicitly searching in a episode 23 of the transcript, which talks about honeybees and some insects or some creatures, right? And it just made the entire response based on this particular episode. So that is a local search, wherein in the global it is taking the entire data set. So even here, the same question is asked: explain the relationship between protein A to disease X. Protein A and disease are both related to gene Z with specific biological pathway. So it gives you they are related with some gene, and that is why they might be interrelated. It doesn't give the entire context of it. So that is what the local search is. I mean, if a data set is tuned that way, or if you want to have tuned that way, you can have a local search perform on your GraphRAG, which would be significantly cheaper and fast. But what I've seen is people rather go with global search because RAG and local search more or less does the same thing. So it defeats the purpose. But again, there could be use cases for local search also, which I haven't seen yet. Okay, then we'll move on to the next slide. We have limited time. Benefit of RAG, I think we've been speaking about RAG from quite a lot. Give you complete and varied responses compared to basic RAG you've seen in the demo also. Generate a response that are better connected to the original data, have more context, have more understanding on the overall holisticness of the data set. Provide overviews of the data set at different levels so user can understand the overall context. Can be more efficient in summarizing the full time. So giving you a very better summary or a theme of the data set rather than the drag, which might rather be hallucinate or give you incorrect data. So this is we have talked about multiple times. Now this is a point wherein we have a large context window increased significantly over the years, right? I mean, since inception, we had 8K initially. I recall we could barely make out of anything in the context window, and then now Gemini offers 1 million. Okay, so what we did is we did a comparison. Okay, so this same data set, which is around 900K token, the Behind the Tech podcast transcript. One hand, it is using GraphRAG solution. On another hand, since Gemini has a large context of 1 million, we've added that as a context in the context itself and then giving the subsequent prompt. Okay, so again, this is 1 million is a window. If you have data which even has larger, more than 1 million, you are bounded by context window, then you would have to rely on RAG solution or similar to RAG solution anyway. But since we have a transcript, we can go with this. So Typically, response time, I mean, in this was 90-second approximate to Gemini, even though it has a context in the prompt itself. And GraphRAG was significantly faster in comparison with the launch context. So 40, 50 to 90, both are slow, to be honest, for a single prompt. But again, GraphRAG is almost twice as fast in a single context window. Okay, now we'll see an example prompt in this scenario. So if you see here, we have asked a question on what food is discussed in the entire podcast. Gemini, even though we have presented the entire transcript, it says pizza and then popcorn, cooking, hosting dinner parties, whatnot. So it actually hallucinate on the other item which is not even there in the context, in the transcript basically. And there are other food items which is discussed which it simply ignored or skipped. And there is a reason for that it does, right? Or there's a reason it does in all scenario wherein you put everything in the large context. So this is the reason wherein often, so we have a response wherein it only has pizza and popcorn for lunch, but popcorn is basically not there in the podcast. So that is hallucination, and cooking and everything else is hallucination, which is not there in the podcast transcript. Now we'll see how the graph rack performs. So what food is discussed, which is accurately saying chip cookies, pizza, African cuisine, Pizza Hut. All of this item which is discussed here is actually there in the transcript. So again, even though they have the same context, Gemini has getting not using RAG, but rather having everything in the context itself, still not giving the accurate result. So what could be the reason for it? The reason while evaluation is, since we ran a multiple of questions, not just this, there were multiple questions tried with this. What understanding is there is a bias when you use a large context window. The bias is the positional bias. So if you send something in the large context window, let's say you send a book, apparently you have a token limit, you send a book. In the large context window, it will only answer in the initial few section of the context. The first section which feed it into the context window. Primarily, the entire response was from the initial context. If you have something important in the middle section, the last section of your context window, it tends to miss out more often than not. So it gives you response, but based on the number of iterations you have run, it tends to miss out in the lower section of your context, middle section of the context. It will only prefer the first position of a context window. And that is where the hallucination and the other answers, or even falling simply flat in responses. So this is a problem with a large context. And again, we had multiple iterations. Like I said, this is just a sample data. Other data set also, news articles, internet data, multiple, which I don't really have a demo of, but again, that is eventually giving a lot of hallucinations. Again, an example, what creatures are discussed, comparing not with basic RAG, but Gemini rather. So Gemini with large context with GraphRAG. So Gemini, even though it has a large context, everything in the large context itself, it is giving this are the creatures discussed, but a GraphRAG gives you a whole set of it. Again, Gemini misses out on few. It gives an accurate response, but it misses out a lot of creatures here. Similarly, a lot of similar questions asked. I think I didn't really kept everything in the slide, but this is one example. I just give one more to summarize it. So Gemini versus GraphRAG on different topic of questions asked. So there's a rating on accuracy and then the comment. So 4 dimension Gemini scored 0 because it was not able to give the entire context. So if you see things here, even though Gemini has the entire context, the GraphRAG actually performed either better or was operating at the same scale with Gemini. In some question, it was better. Like in Gemini, the food mentioned, Gemini fall flat, GraphRAG gave an accurate result. There was only one thing wherein the Gemini has a better understanding, wherein whimsical things, wherein materialistic multiple things in the first. So there was a question set which only focused on first few episodes of transcript. Okay, so if the question is from the first few episodes of the transcript or the topic, Gemini tend to have a better response. Let's say you send a lot of text, but if you only ask a question from the first initial few subset or data set in the entire context, then the Gemini perform better because it only taking the initial few as the primary data set and giving more detailed responses. Okay. Then the GraphRAG, but everything else was GraphRAG was even either equal or even better in the scenario. Now coming to the next point, since you guys have seen GraphRAG is slow and consumes a lot of token, so that becomes expensive because OpenAI or Azure OpenAI, what do you call it, are built based on consumption of tokens. The number of tokens you consume, that's how you build it. That's how you're getting built. So that becomes a costly solution if your solution is consuming a lot of GraphRAG. Now, a lot of problems of this GraphRAG scenario can be solved using an SLM. Okay, so a lot of data scientists in Microsoft Research have tried different SLM models for most, not all scenarios, but for most of scenarios, and found they are pretty accurate to GPT-4 also, given the kind of data set they have given with. And now SLM has a very low, either you can host it on your own node, or you could use Hugging Face or our own AI Studio, which has all the open source model also, and very cheaper to maintain, right? Cheaper to use because it has a very low billing consumption based on token than the typical large language models. So using all this different SLM models, the response was more or less same or slightly degraded, not at par with GraphRAG, but I mean not at par with LLMs, but more or less similar in a case of a standard GPT-4 LLM. Okay, and so that is why the recommendation is considering the solution you build. If you have a specific data set, use, let's say we have a 5.3 also, 5.3.5 as a SLM to use it because you are only going to ask question based on your own data set. You don't need to have information of all the knowledge of the world. So yeah, this is the recommendation use with GraphRAG, considering the speed and the cost that comes with. And we've seen this visualization, which is visualization of a, once you have a graph database, there are graph different tools which could basically give you visualization of a data set. How does it look like on a visualization? And I mean, yeah, we have, I think we're pretty aware where to use GraphRAG in what scenario. So this is an example of, remember I gave an example of a friends, right? This is some fantasy gaming character, an example wherein Dorothy, Toto, and each have a relation with each other. So there are each Kansas is a topic, Dorothy is a person. Each of this main subject becomes an entity. Each circle is an entity, and then this relations, which is friends and enemies, these are your edges, which it says. Okay. So this is, I think we are top of the hour. I had few slides. I mean, just for the safer side, in case my demo doesn't work. So this is where we talk about in case we couldn't get the demo something happened on demo. I just had this in backup, but this is giving the same line wherein a different data set, Novo Russia. So this is giving a detailed study in the conflict between Russia and Ukraine. There is a book, so that has been used as a data set, and this is where we're asking questions based on that book set. Novo Russia is basically the new Russia post the post the earlier Asian period. That's what referred in the book. So there are prompts, and you see a response in baseline RAG, which is very pretty generic, but GraphRAG gives you very detailed uh, description. Wherein baseline is giving you answers, obviously, but not the detailed answers, which is still fine. But in some scenarios, what has Novo Russia done? So basically, what has Russia done that has led to the conflict of Ukraine? And the baseline RAG in this context is doesn't have a context because it doesn't really understand that in a semantic search. Wherein the GraphRAG, considering it has a entire GraphRAG, it is giving you what has Russia done. Russia has carried out multiple attacks in Ukraine and different, if you see radio, television, a lot of things, private bank, ATM, whatnot. So whatever has been done by Russia so far, it is giving a response wherein the baseline RAG falls flat. I think this is the same thing. So GraphRAG, con. So this is giving us the sample example. So here I think vectorization cost would be 0. So in here the cost is something which is a con for a GraphRAG because it makes a lot of LLM calls and utilize a lot of tokens considering it takes to build a knowledge graph. So and it is time consuming and it is the search is slow because it makes a query the entire data set. And for comparison, if you want to vectorize an entire 250-page book, you would have cost 0.056 with a GPT 3.5 or GPT 4.0 in here, but with the GraphRAG solution, you would have cost. This is a sample. I mean, very broadly exaggerated cost, but just to give you know, this is an expensive, considering you've seen the token consumption and everything, right? So yeah, I think this is the downside of using GraphRAG. I think that's all I had.